Good morning, everyone. Thank you so much for joining us today for our webinar. Our topic today is DMR QA, Solids, Products, and Tactics, and our presenter is Brian Miller. I'm Christy Addis, and I am the Senior Product Marketing Manager at ERA. The first slide that we have here is just to give you some housekeeping details. This is the council page that you see on your screen. We've got the slides there, Brian's information, survey questions, resources, and question and answer window. We will not be doing a live question and answer section at the close of the webinar, so we ask that you put your questions into the question and answer block, and we will follow up with you shortly after the conclusion of the webinar. So our topic today is DMR QA Solids, Products, and Tactics. And this talk will focus on the tips for success to ensure success for the upcoming DMR QA 41 requirements. Our key learning topics today are solid samples, what are they, methods, make yours work, and analysis tips, ensure success. Our speaker is Brian Miller, as I mentioned prior to that. Brian has 21 years of experience working in the environmental testing industry with experience in inorganic, organic, and radiochemistry. Brian obtained a Bachelor of Science degree from the University of Wyoming and is currently the Inorganic and Radiochemistry Technical Manager at ERA. He has analytical testing and data validation experience from 2 radiochemistry laboratories and analytical testing from the Colorado State Toxicology and Inorganic Laboratory. Brian is a member of the T&I Radiochemistry and SASS expert committees. With that, I'd like to turn the floor over to Brian and thank him for his time today, and thank you all for attending.
Thank you, Christy. I'm Brian Miller, and in this webinar, we will cover solids for the DMR QA study. Total solids are dissolved solids plus suspended and settable solids in water. Dissolved solids are particles that can include calcium, chlorides, nitrate, phosphorus, and iron. Dissolved solids are particles that will pass through around a 2-micron filter. Suspended solids can be silt, clay, algae, and fine organic particles. Suspended solids are particles that will not pass through a 2-micron filter. High concentrations of dissolved solids affects the water balance of aquatic organisms. High concentrations of suspended solids can serve as carriers for toxins. Total solids affects water clarity and can make drinking water unpalatable. Total solids are important to measure in areas where there are discharges from sewage treatment plants, industrial plants, or extensive crop irrigation. ERA offers several products for the DMR QA study. The products listed also include other parameters making the test options more efficient. Our solid sample is a 500 ml full volume sample requiring no dilution. It contains TSS, TDS, and total solids. Our mineral sample is also a 500 ml sample containing TDS, TS, and our mineral sample also contains a list of anions, cations, along with alkalinity and conductivity. A hardness sample contains total suspended solids plus calcium and magnesium for hardness testing. We also offer a settable solids sample and a solids concentrate sample. Both samples are sold in the solid form and require the solids to be rinsed from the containers into a final dilution. Listed here are several approved methods for testing solids. They include the EPA 160 series, the Standard Methods 2540 series, and ASTM methods. Here are some tips for sample preparation. When analyzing samples which require a dilution, for example, ERA's solids concentrate sample, for best results, analyze as soon as possible after the dilution is completed. Make sure to use an adequate amount of sample. A larger sample volume will increase precision and accuracy of the final result. For samples in which suspended solids are being determined, make sure to mix the sample extremely well. Some suspended solid particles are heavier than water and will settle to the bottom of the sample container. Suspended solids in both field samples and in ERA's PT samples can adhere to sample containers in sample testing glassware. For example, beakers, graduated cylinders, and vacuum apparatus equipment. Always rinse all glassware and containers thoroughly with DI water at least 3 times to ensure that all suspended solids have been captured for analysis. Environmental conditions can play a big role in the accuracy of solids measurements. Always consider the environmental conditions within the laboratory when performing any solids analysis. The 2 main environmental controls to consider are temperature and humidity. Make sure the temperature and humidity in the lab is consistent from measurement to measurement. Fluctuations in the temperature and humidity can cause differences in the dry weight measurements. The more mass of residue that is on the balance, the less the environmental controls come into play. Sample drying tips. Make sure to follow your procedure to ensure that the sample is completely dry. Once the dry weight is measured, place the sample back into the oven for at least 30 minutes and reweigh your sample until a constant weight of less than 0.5 milligrams or less than 4% is achieved. Here are some sample cooling tips. When cooling samples, the use of a desiccator will help ensure that you are not introducing moisture. Check that the desiccant is dry and change it when needed. Make sure to cool samples for the appropriate amount of time. Ceramic crucibles and glass beakers will take longer to cool than aluminum pans. Although the crucibles and beakers feel cool to the touch, if not completely cooled, the dry weights can be affected. Allow at least 1 hour for the containers to cool. Be sure to cool the samples for equal amounts of time for each drying event. Dry weight measurements. When performing gravimetric methods, the main goal is to ensure that you can accurately and appropriately read the amount of residue left in the pan. If available, use a 4-place balance when performing the method. Solid residue can be very light in weight, so a 4-place balance can help with accuracy and precision. Here are some suitable solids analysis tips. For best results, use Imhoff cones that contain a measurement scale with increments of 1 to 2 milliliters that goes up to 100 milliliters. Timing is the key to successful measurements for this method. Let the sample settle for 45 minutes, then gently tap the sides of the cone, wait 15 more minutes, then record the volume of the settable solids. Lastly, we will discuss some quality control practices for solids. Make sure to include a routine quality control procedure with each analysis. Be sure to include blanks and certified reference materials with each analysis. Blanks and certified reference materials will help regulate environmental controls and determine if the analysis was performed correctly. Blanks that exhibit high positive or negative values can be indicative of a procedural problem. Additional resources on solids and other products and methods can be found at our website at www.eraqc.com.
Well, thank you, Brian, for giving us that presentation today, and I'd like to thank everyone online for attending. Again, our question and answer will be followed up after the webinar, so put your questions into that council page. And again, thank you for your time today. Have a great day.